All right, here's the 5.4 homework assignment. In this first problem, they give you the lengths of all three sides of this triangle. Kind of annoyingly, they don't write them in the picture. They tell you A equals 91, B equals 60, and C equals 109, or whatever your numbers are. Note that the triangle is not going to be drawn to scale. It's just an arbitrary triangle. It's always going to look like this. But they give you those three values here, and then they ask you for the values of each of the 6 different trig functions we have of the angle A. So note the orientation is a little bit different than what we're used to, but that's fine. A is down here, so you're not concerning yourself with this angle B, but instead this angle. And if you want opposite of this angle, for example, we're talking about this side. Adjacent to this angle would be this side. Maybe using SOHCAHTOA, you could figure out the values of each of these 6. You just write them as fractions. I don't even think you have to reduce those fractions. Put those in, and then you're done with this problem. Hopefully it'll go really quick for you. Question 2 is very similar, except they only give you A and B. Oh no, how am I going to figure out sine? Sine is supposed to be opposite over hypotenuse. I need to know what C is to use opposite over hypotenuse. Right, but if you know 2 sides of a right triangle, really you know all 3 using the Pythagorean theorem. So maybe you can solve for C and then figure out all of these guys. And it's worth pointing out it's good practice to get into the habit of rationalizing the denominator, although I believe this problem will mark it correct whether you rationalize or not. So I guess what I'm saying is as long as you could rationalize it, like on a quiz or something, then you don't have to do it over and over again in the homework. But if you're not sure that you can, maybe get practice in the homework by rationalizing the denominator in each of these ones. Question 3 is almost the exact same. In fact, it's so similar that I think I'm not even going to waste your time. I think I'm going to get rid of question 3. Originally, I left it in there because this is a really good skill to have. And I was like, maybe if they do it twice, they'll get better at that skill. But I think I trust you guys enough to make sure you understand how to do question 2. And if you can't, go back to the notes and maybe practice a new one on your own. And as long as you're good with question 2, you won't have to do this one. So I'm going to get rid of this problem. So what you'll see for question 3 won't look like this. And instead, it'll look like this. And you're like, whoa, it looks the exact same. Not really, because down here, they're not giving you 2 of the lengths of the legs of a triangle. They're instead telling you the length of one of the legs and the measure of one of the angles. However, that angle will be one of the values on your unit circle. So maybe like we did in the first video in this section, you'll be able to solve the triangle. Right? They give you one of the side lengths, so you'll need to figure out the other 2 side lengths. And they give you 2 of the angles, really, angle A and this right angle here. So you have to figure out the other angle. So really what this is asking you to do is solve this triangle, which is the same thing question 5 is asking you to do, except now it's a different triangle. But again, the angle that's given is an angle on your unit circle. And as long as you have one of the side lengths, you can solve for the remaining side lengths and the remaining angle. Note that it says to give all your answers to at least 1 decimal place. What I would probably do, unless it prohibits you from doing this for some reason, is leave them all exact. Write them as fractions and stuff. That's how I'd want them to be on quizzes. But whatever. I guess it's allowing you to get away with 1 decimal place. If you really want to use a calculator, feel free. Question 6. Whoa, this looks totally different. Word problems. I'm not used to this. Well, yeah, 6 and 7 technically are both word problems, but I think what you'll see is really they're the same as 4 and 5. I think if you read through this problem, a 24-foot ladder leans against a building. Presumably that building goes straight up. So sort of picture the ground, and then the building goes straight up. We kind of have a right angle there and a ladder leaning against it. Maybe you can kind of start to see the outline of a right triangle. At any rate, the angle between the ground and the ladder is given to be 78 degrees, and we're supposed to figure out how high the ladder reaches on the building if the ladder is 24 feet long. Really, what I think question 6 is basically question 4 or 5 in disguise, in that they're giving you 1 side length and 1 angle, and you're asked to figure out some other side length. It's worth pointing out that the angle here, 78 degrees, is not one off your unit circle. 45 degrees, that is. 30 degrees, that is. But 78 is not. So this will be one of those cases where your answer will be an expression, unless you're using a calculator. So maybe your answer will contain sine or cosine or tangent of 78 degrees and 24 in some combination, and that'll be the length of the ladder. And then 8, 9, and 10, the last 3, one of them's extra credit, you can kind of pick. They're all kind of the same thing in that you'll have to do multiple steps to figure out what they're looking for. So in this problem, they're asking for x down here. And you're like, wait, is that adjacent or hypotenuse or opposite of this big triangle right here? And we don't know because we don't know anything about this big triangle here because it's not a right triangle. Oh, bummer. But we do know about this little triangle right here. And we know about this triangle over here because both of those are right triangles. So maybe you could figure out the distance from here to this point and the distance from here to this point, and then just add the 2 of those together to get your answer. Sort of the same idea down here. I'm supposed to figure out the distance from here to here. Whoa, the side length of a triangle that's not a right triangle? How could I possibly do that? Well, you have this little right triangle here, and then you have this bigger right triangle here, and maybe the difference in a couple of different side lengths would end up giving you this value here. Finally, question 10, you're supposed to figure out this side length, which is hard because in this triangle, I don't have any information about any side lengths, right? But you have this triangle over here, and maybe there's a side length that the two triangles have in common that you can figure out from this right triangle and then use with this right triangle to figure out x. Try these 3 out. If you can do them, great. This isn't something I'm going to test you on, but I think it is a good skill to have. A couple comments here, though. The angles that you'll see are not values off your unit circle, so that'll be kind of annoying. Your answers would be expressions, and I don't even know if they'll let you type in expressions here, like 34 times the tangent of something. I don't even think it'll accept that. It needs your answer to be a decimal or an integer value. So in order to get these right, you'll have to pull up a calculator or just use Google. If you just type in something like SIN 30, it'll figure out the sine of 30 for you. But be careful, the calculator that Google pulls up always assumes you're in radians. So it's telling you the sine of 30 radians. That's not what you want, right? You want 30 degrees. So what you have to do is convert degrees into radians so that this Google calculator will understand it. Remember, the way you convert degrees into radians is you multiply by pi and then divide by 180. So if you wanted to know the sine of 30 degrees, you type in the sine of 30 pi over 180, and then it would figure that out and give you this 1/2 value right here. There's lots of other ways you can do it if you have a calculator handy. Maybe something that looks like this. You can use the sine function, but again, be careful. You put in sine of 30 and you don't get the value you're expecting. And that's because this calculator is in radian mode. So I would have to hit this mode button up here and then switch it from radians to degrees if I really wanted to tell it degrees. Now when I put in sine of 30, I get the 1/2 value that I was looking for. If you can't figure out how to switch your calculator from degrees to radians, you can deal with radians. You just have to ask it, if you want the sine of 30, what the sine of 30 pi over 180 is equal to. Pi in this calculator is hidden above this key, so I hit second and then this little caret and then divide by 180. And now, even though I'm in radians, I can figure out the sine of 30 degrees. It's equal to 1/2. And you're like, whoa, so we're using calculators now? No, we're not using calculators. If this were on a test, which it wouldn't be, this would be 45 degrees and this would be 30 degrees maybe. Or this would be 60 and this would be 45. I'd have to choose values off your unit circle if I wanted to ask you questions like this. Otherwise, you'd just leave your answer as an expression, like 34 tangent of 47 or whatever it might end up being. Sorry for that little bit of annoyance, but I kind of like questions 8, 9, and 10, even though I don't like the way you input your answers, so I wanted to leave those up on here. That's the end of this homework assignment.